All right, so the definition of a parabola is it's the set of all points in a plane that are the same distance or equal distance from a given point called the focal point or the focus and a given line called the directrix. So the idea of a focal point is new to a parabola. The idea of a directrix is new. And the last thing I want that's new that we're going to point out is the distance from the vertex to the focus or the directrix is given by P. We call that length P. So if I were to draw a little picture here for you, let's say here's my parabola, here's my focus, and then here's my directrix. The distance from here to here is called P, which is the same as the distance from here to here, which is called P. Now, the formula is defined as 1 over 4a. We are familiar with this a value. That a value is the same a value that's in ax squared plus bx plus c. It's the same a value that we have in our formula here of graphing form. All right? So that a value we're familiar with. Now, I want to start with the vertical parabola because this is something we're most familiar with. And let's start by identifying the vertex. So the vertex of this particular parabola is what coordinate? 4, 2. 4, 2. And in any parabola, the vertex is our HK. But specifically in our first example, it's 4, 2. If I wanted my axis of symmetry, you guys could find the axis of symmetry, right? With a vertical parabola, the axis of symmetry is a vertical line that runs through that vertex. Vertical lines start with x equals, and it's going to be x equals whatever that h value is. So in my case here, for this example, I'm going to have x equals 4. That's my axis of symmetry, my line of symmetry. Okay? So far, nothing new. If I wanted to find the a value, first semester, we found a second point on the parabola, and we either plugged in the HK and solved for a, or we used the counting scheme. You guys remember what the counting scheme is? Yes, you do. The counting scheme is the parent function. The parent function is 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So wherever your vertex is, you would go over 1 and up 1, over 2 and up 4, over 3 and up 9. So let's look at the vertex here. Did the vertex go over 1 and up 1? So the a value is 1 for this example. A equals 1. So if I have HK and I have A, I am able to write the equation of this parabola, right? Y equals my A value, which is 1, x minus 4 quantity squared plus 2. That's stuff we did first semester. Now, the only pieces that are new now is we want to, well, and we know this is concave up. So when our A value was positive, we had a concave up parabola. And when our A value was negative, we had a concave down parabola. So here we were concave up. So here are our new pieces. I need to find I need to find the value of P. Okay? So my value of P, let me change colors here. P equals 1 over 4 times A, and we just said that A is 1. So P is 1/4. So that means 1/4 of a unit inside the parabola is my focal point, and 1/4 of a unit outside my parabola is going to be a point on that line. All right, so I have 1/4 of the unit down from, what is my y value right here? What's my y value in the vertex? 2. So if I am a fourth of the unit down from that, what's the y value of my directrix? 1 3/4. Okay, so that is the equation of this, y equals 1 3/4. That's the equation of my horizontal line. So if I want to find my focal point, right, my focal point, it has the same x value as the vertex. So my vertex is still, my focal point still is 4, but instead of my y value being 2, it's 2 plus a fourth. So this is 2 1/4. So that's the coordinate of my focal point for this scenario. All right? So I have a little formula, but note I didn't use that formula. I just reasoned myself through this. So here's the formula that you can use if you want, or you can reason yourself through it. So to find the directrix, we have y equals, we took the k value in our vertex, and we either add or subtract the p depending on if we're concave up or concave down. All right, and then to find the focal point, it's h comma and then k plus or minus p. And if your directrix is plus p, your focal point will be minus p, and vice versa. Okay, so other than those last two pieces, that should be a review. Now, here's what's new. Let's look at our parabola that's opening to the right. So your parabola will open to the right when your a value is greater than 1. And your parabola will open to the left if your a value is negative. All right? The vertex, though, is still going to be hk. I'm still going to find the coordinate. So let's go ahead and do that. For our sideways parabola here, the coordinate is +2, +3. That's our hk. Okay, it's still +2, +3. Now, I want to find the a value. So I'm going to find another point on this graph. That's easy to see. This one looks like it's easy to see, right? And honestly, if I could, with my paper, I would turn this so that it's concave up. And that way I can do what I'm used to doing. So if I could turn my board, what is that, 90 degrees, I would. So I'm going to go back to that counting scheme. I like the counting scheme. So when we went over to look at this graph, if this was concave up, we would be going right 2 and up how many? 2. Well, what does the parent function tell me to do when I go right 2? I go up 4. So what do I have to do to 4 to get to a 2? I have to multiply it by 1/2. That's my a value. That's my a value. Because I'm going over 2 and up 2. If I had turned my paper so that it was concave up, from the vertex I would go to the right 2 and up 2, which means my a value is 1/2. All right, so here my a value equals 1/2. Well, I have enough information to write the equation. Now so we have to be careful here. We start with an x equals, my a value is 1/2, parentheses y. Inside the parentheses, we change the sign. So I'm going to take my k value this time and change the sign, quantity squared, but I'm not going to change my h value. So it's the opposite of what we did when we wrote concave up and concave down parabolas. We change k because it's inside the parentheses. We don't change h. All right. Can we do an axis of symmetry here? Yeah, we can do an axis of symmetry. An axis of symmetry this time is going to be a horizontal line. Horizontal lines start with y equals. So this is y equals, and I'm just looking, this is y equals 1, 2, 3, y equals 3. If I want, what is the 3 the same as, the h or the k? is k. So I could write y equals k every time here. Y equals k. So generically, that's what we have. And so now I need to move on and find that p-value. So p is equal to 1 over 4 times 1/2. So what's half of 4? 2. So the p-value is 1/2. So that means a half a unit inside the parabola will be my focal point, and a half unit outside the parabola will be that directrix. Well, that's not quite a half unit. I need to play with that just a little bit. Move this over. There we go. That's about a half a unit. And I'm going to change the color if it lets me. Oh, thank you. To the left, to the left. Okay. So there's my direct. So now I need to write my equations and my ordered pairs. Well, so I'm looking, my vertex is at 2, 3. So this point here is a half a unit to the right. So it's 2.5, 3. Right? My focal point, my focal point equals 2.5, 3. 2.5. 2.5. Because I went a half a unit to the right. Right? This is the distance. I started here at an x value of 2, and I added a half, so now I'm at 2.5, 3. Directrix. So if I'm going to the directrix, well, this is a vertical line. Vertical lines start with x equals. This x equals is 2, right? My x value is 2, and I subtracted a half from it. So this is x equals 1.5. That's the equation of my line. So I was messing with that h value this time. All right, so this is x equals h plus or minus p, and h plus or minus p comma k. Knowing that if your directrix is plus p, your focal point will be minus p or vice versa. But I'm telling you, I almost never look at these formulas. I just look at my point and say, okay, I'm adding this, so I need to, which way am I moving on the x-axis kind of thing. All right, you guys ready to practice? Let's practice. All right, so what way is this parabola going to open? Down. It's going to open down. Does it say direction? Yes. And I know that because, one, it's y equals, so y equals will be up or down, and because my a value is negative, I'm going to open down. All right, what's the vertex of this parabola? Positive 3, positive 2, so let me plot that. Positive 3, positive 2. And the a value we said was negative 1 over 8. Okay, so John, this might answer your question. So to do this, I'm going to go to my counting scheme again. What I did first semester, we said 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And I'm going to multiply all those y values by negative 1/8. Now, so I really only care about the ones that are kind of pretty. So if I multiplied 4 times negative 1 over 8, I'd get negative 1/2. Negative 1/2. I can't even see that. Negative 1/2. Negative 1/2. And if I multiplied 16 by negative 1 over 8, I would get negative 2. All right? And those are the only points I'm going to worry about. So from the vertex, what's my first move? Over 2 and down a half. So over 2 and down a half. So I have this point here and this point here. From the vertex, I'm going to go over 4 and down 2. Over 4, 1, 2, 3, 4, and down 2. This point, 1, 2, 3, 4, 1, 2. Right, it's really wide. It's really wide. I've got a vertical compression going on here. 6 squared is 36. 36 divided, no, it doesn't work. Okay, so I'm just going to go with these guys. So here is the graph of my parabola. So what's the axis of symmetry? Here we go through here. Oops, yeah, it's supposed to be dashed. I'll fix that in a minute. There we go. X equals 3. Good. There's my axis of symmetry. X equals 3. So all of that I've done so far is all the old stuff. Okay, we could have done that first semester. Now, what's new is I'm going to find my p-value. My p-value is 1 over 4 times a, which is negative 1 over 8. So 4 times negative 1 over 8 is negative 1/2. What am I doing when I'm dividing by a fraction? Multiply by the reciprocal. 1 times negative 2 over 1. So my p-value is negative 2. Now, I don't want you to worry about the sign. I just want you to think about the distance, like the absolute value is distance. So p is 2. So 2 units inside the parabola is your focal point. 2 units outside the parabola is a point on the directrix. Okay? So this one will be easy for us to get the coordinates of because they're nice whole integers here. I'm going to draw my directrix going through that point. Maybe I'll change the color of it so it stands out a little bit better. There we go. And so now I can write the coordinate. So the coordinate of my focal point here is, let's see, here's 0, 0, so it's just 1, 2, 3, 0. And the directrix, here's 0, 0, positive 1, positive 2, positive 3, positive 4. Y equals positive 4. Okay? One more. We're going to just do one more. The one that the examples on the back of the paper, we're saving until Monday. Okay, this is, which direction is this parabola opening? Left. Good. I know it's right or left because of the x equals, because it's negative, I'm opening to the left. To the left, to the left. Okay. What, I know I can help myself. What is the vertex here? Be careful. Positive 5, negative 4, because this is the K, this is the H, so I'm going to write positive 5, negative 4. I'm going to plot that point. Positive 5, 1, 2, 3, 4, 5, negative 4, 1, 2, 3, 4. All right. My axis, well, let me draw a little bit of it. Okay, so I'm going to go back to that parent function again, where I have 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And what am I going to multiply all the y values by? Negative 1/4. Negative 1/4. So here it gets pretty here, negative 1/4. So that'll be negative 1. And if I multiply this by negative 1/4, it's going to give me negative 4, right? Knowing that we have to go to the left. And again, if it were me, I'd probably just take my paper and turn it, this time turn it 90 degrees clockwise, and then do what you're used to doing. But I can't do that with my big board here. So I'm going to, from my vertex, I'm going to go over 2 and up 1. Over 2 and left 1. From the vertex, I'm going to go over 4, 1, 2, 3, 4, and to the left 4, 1, 2, 3, 4. Over 4, 1, 2, 3, 4, and to the left 4, 1, 2, 3, 4. But again, if it were me, I would just turn, I just turn my paper and do what I did first semester to find those points. All right, so let me connect these. All right, So now I can draw my axis of symmetry here. Right here is going to split this in half. What's the equation for this axis of symmetry? Y equals -4. All right, so that's all not too bad. So now I'm ready to find my p-value. So p equals 1/4 times -1/4, which equals 1/-1 or -1. And again, I don't care about the sign. I just am interested in the distance. The absolute value of that is 1. 1 unit inside the parabola is my focal point. 1 unit outside the parabola is going to be a point on the directrix. So I'm going to draw my directrix here, which should hit here. Bam. And let me clean this up a little bit. Properties. Make that red maybe. All right, so how do I write the equation of the directrix? It's a vertical line, so we start x equals, and this one I can just count 1, 2, 3, 4, 5, 6, x equals 6. So then here's my focal point right there. So the x value is 1, 2, 3, 4, and the y value is -4. Notice that here my p-value is 1. So my vertex, 5 minus 1 is 4, 5 plus 1 is 6. Okay, so you can kind of check that way.